Welcome to this video on finding tangents. Tangents are extremely important for finding rates on curved lines. So when you did your velocity time, your position time graph for the buggy, you got a graph that looks something like this. It's curved. It's curved because the rate of change in position is changing. The speed is changing. Down here we have a not very steep line. At the beginning of the ramp, the car wasn't going very fast. But at the end, the car was traveling quite quickly, and our line gets very steep, much steeper at the end. So in order to find the velocities, there's two different ways we can find velocities, actually. We can find the average velocity, or we can find the instantaneous velocity. So if I want to know average velocity, I want to know the displacement. You can't see that, I need to write in darker. To find the average velocity, you need to find the displacement divided by the time. So to find average velocity, what I would do is I would find the first position and the last position, and I would draw a line connecting those two. And this line then would be my marker. This isn't going to be as precise as yours needs to be. You should be using a very sharp pencil when you do this. So this line right here represents my average velocity. My total displacement, my starting point, my ending point divided by the time. So the slope of that line would be my average velocity. Over time, total time, that's what it would be. But that doesn't tell me how fast it's going here, or here, or here, or here, or here. So if I want to know how fast it's going in all of those places, then I have to find my tangent. Now a tangent is a straight line that touches a curved line at one point. So the edge of the ruler there is representing the tangent. Or I can move it to a different part of my curved line, and I have a different tangent, I have a different slope of a tangent. Or I can move it down here, and I have a different slope of a tangent down here. So we're going to find the tangents. How many places are we finding the tangents? Will you let me look it up? We are finding tangents. Well, let's do 4 tangents. So I'm going to, let's find my tangent at 7 seconds. So my tangent at 7 seconds. To look like this. I'm going to draw the line as long as I can. An important tip here, and I'll label it right now. So t equals 7 seconds. Now I'm going to find the slope of this line. And I'm going to use points along this line that hit the grid exactly, anywhere along this line. So I'm going to use this point right here. I'm going to use this point right here. And I'm still labeling these points like I should be. So y1 equals 9 meters.
Just a reminder that those are interested in helping with the Outdoor Learning Lab Committee, we're meeting in the Media Center conference room right now. Thanks.
So x1 equals 16 seconds. y2, 14 meters. x2, 16 seconds. And I'm going to find my slope, it's called velocity, my velocity, which is y2 minus y1, over x2 minus x1. Your paper is going to get very crowded, so make sure you're keeping track of what and where. So this is 14 minus 9 meters over 16 minus, not 16, 24. 24 minus 16. calculator for that. When you're putting this into the calculator, make sure that you're telling your calculator to do it the right way. If you want to do it all in one go, you have to use parentheses for what's on the top and what's on the bottom. So here my velocity equals 6.63. Let's do two significant figures, meters per second. I'm going to go back right up here, 0.63 meters per second. So at the end of my line, I have my time and I have my velocity. I'm going to take that and turn that into a t-chart as soon as I have some more. So now I'm going to draw a second tangent at a different point along the line. Let's try and get kind of the beginning, middle, and end. So let's do a tangent right there. And I'm choosing specific seconds because it makes that part a little bit easier. And I'm kind of symmetrical on each side of my line here. I'm going to draw another tangent. I'm going to label it right away as time equals 15 seconds. I'm going to find my slope. I'm going to use 2 points along the line. Use that one. Use that one. And we're going to calculate the slope. We're going to find the velocity. We're going to do another one. Working our way up. Let's do one right here. Again, I'm balancing my ruler so it's symmetrical. Drawing my line the whole way. So here is time equals 20. And find the velocity. And then one more. Towards the end, our data sometimes isn't as clear as we'd like it to be. So maybe I'm going to take one down here at the beginning. Let's take one here at 3 seconds. 16 equals 3 seconds. You're going to have lots of calculations on this page. Keep them all straight. Make sure you're labeling all numbers at all times. So now that I have all of them, I'm going to go back and I'm going to make my data table. I'm going to plot my time as a column, and I'm going to plot my velocity as a column. So I have t equals 3 seconds, and whatever that velocity was. I have 7 seconds, 0.63 meters per second. I have 15 seconds, and I have 20 seconds. Now I'm ready to plot my velocity versus time. Have a good day.